Good evening, madam. We are happy to note that we are back with science pedagogy going ahead, and we are getting very good feedback from the children. So we are also happy they are happy. So we will
Thank you very much, sir.
Yes,
Good evening, sir, and good evening to all the viewers here who are going to view the next session here with regard to our science pedagogy, CTET paper 2 by Dr. Yakaiah and team. So welcome back again. And we are going to today see with the third chapter of our pedagogical issues in science, that is understanding and appreciating science. Okay. So here, understanding and appreciating science, it means to enable students to understand the main ideas and concepts of science and to apply them to solve problems in familiar and unfamiliar situations. And students are expected to develop critical and reflective thinking and judge the credibility of the scientific information. So here, with respect to the understanding of science is extremely important because the child needs to understand the ideas and the concepts, the facts, the theories, the laws, the generalizations of science, and to apply them in solving the familiar and unfamiliar situations which he or she faces in day-to-day life. And students are expected to develop critical and reflective thinking. Critical thinking is extremely important to understand why this has happened and to again to reason out. And reflective thinking is nothing but to reflect back how and the processes of science occurs and why such process of science occurs, and to reflect back on it and judge the credibility of scientific information. A pedagogical shift has been there from the perspective of nature of science, from mere substantive and syntactic structure to perceiving science as a particular way of looking nature, like to understand the various causes and effects of nature, spreading the concepts of science into interdisciplinary areas of learning, and much beyond it, making science as a truly international enterprise with international collaborations for scientific development. So we previously noted down that we had a nature and the structure of science with respect to the substantive and syntactic structure of science, but now there is a pedagogical shift with respect to the constructivism theory, and it has been implemented in science in all subjects as well. So it refers to that we are going beyond the substantive and syntactic structure of perceiving science, and we are looking at nature, and we are trying to see in a different angle to the nature and understand the various causes and effects in the phenomena of the nature, and spreading the concepts of science into interdisciplinary areas of learning. Interdisciplinary areas means just from one area to the next area and from one discipline to another discipline, and how these concepts occur in different subjects and in what ways, in what phenomena, in what topics it refers. Like for example, we have the environment, and we also have the different environmental cycles like the water cycle and all the different types of cycles which we definitely study in the environment. So how the concepts are getting related, and much beyond it, making science as a truly international enterprise to see to it that how collaborations are being made up from one country to another country to solve the major issues, especially regarding the environment and the climatic changes. Now here, the next one, let us see the conceptual understanding and the application to daily life situation. This is what is the first learning outcome in science education. So previously we have already seen how the pedagogical shift is there. Now next we are seeing that how there is a conceptual understanding and application of science to daily life situations. So the first learning outcomes, that is, once we teach the science subject, what we are expecting of that at the end, that is the learning outcome of science education, what the child must imbibe or must we inculcate in science in the children for the subject. And the first is that the conceptual understanding and application to daily life situation. So here children are able to explain, cite examples, give reasons and give comparison and differences, explain the process of given concepts in the textbook, children are able to develop their own brain mappings here. So they are able to understand different concepts, and they are able to recognize, recall, explain, and give examples on different topics, and they are able to try to understand why the things are happening, and they try to compare the different phenomena, and they try to bring out the differences between two different things and explain the processes of different theories and or the given concepts in the textbook. And children are able to have their own brain mappings. They are trying to able to understand each and every bit of knowledge. Next, we have the next learning outcome is the asking questions and making hypotheses. So in this, children are able to ask questions to understand, to clarify the concepts, and to participate in discussions. And they are also able to make hypotheses on given issues. So they need to see to it that how they are making out hypotheses, how they are asking questions to understand the topics in science and to clarify the concepts and to participate in discussions. They are able to make here the hypothesis on given issues. Like for example, if we give a child the situation of why a particular flower has a particular color of pink or another color red or yellow. So there are different colors in the different flowers. So how these colors occurs, why this colors are there, and that is again they can just try to have some kind of a reason. They can make up their hypothesis on it, and they can understand, and then they can do some kind of experiments. And then later they can also take up white flowers and put some color in the pot, in the sand, like if they add the pink color in the sand into the pot, and then ultimately it will reflect in the color of the flower. So the white flowers will turn into pink flowers. So such kind of a hypothesis, some experiments can be done here. Then the third one is nothing but our own experimentation. That is to understand given concepts in the textbook. Children are able to do experiments on their own, and they are also able to participate in field investigation and making reports on them. Yes, once the experiments start, they are very keen on trying to observe the result of the experiment and how the procedure of the experiment goes on, and they are able to note down and record the observations in their notebook, and then they are going to make a report on that. So all these things happens in the experimentation. So experimentations give them the hands-on experiences in trying to understand the different concepts of science, and they are able to participate in different field investigations, and they again try to by own themselves they will be able to do their experiments. So this is what we are inculcating, the habit, the skill of experiment in the young children. Fourth is the information skills. Children are able to collect information by using interviews, internet, and diverse resources, and analyze systematically the different information which they have collected, and they are able to conduct their own project works. So this the child must be able to do. So they should be able to see that how the information is available, and how they are collecting the best of the resources and the best of the information from the resources, and how they are analyzing each information systematically and trying to put down in their project works, using that information for doing some projects. Next is communication through drawing models. Children are able to explain their conceptual understanding by drawing figures, in making models by pictorial or diagrammatic or graphical representations, and they're able to plot graphs by using given information or collected data. Sixth is concern towards biodiversity. Children are able to utilize scientific concepts to face their daily life situations. They are able to show concern towards biodiversity. So here it's extremely important, like they have some concern towards biodiversity, and they want to see to it that how they can try to solve out many issues of this biodiversity, and how they are able to keep on doing the experiments and show concern towards biodiversity, and how they can try to protect the environment. Then the seventh one is aesthetic sensitivity and appreciation. Under this, children are able to appreciate manpower and nature and have aesthetic sense towards nature. They are also able to follow constitutional values. So they are trying to see to it that how they are appreciating the manpower and nature, how what man does with nature, how man utilizes the nature, the natural resources, and what are the new inventions, and how we can try to protect the nature, and have the aesthetic sense towards it. And they are also able to follow constitutional values. So what according to the rules and regulations are, so they are able to follow those, and they are able to have the appreciation towards this. So this is an important kind of learning outcome, where the child must have some aesthetic sensitivity and appreciation, so that they do not destroy the nature. And then we will see here the objectives of science teaching, that is the science curriculum at different levels, as we have already seen this in the previous session. So I'm just going to see to it that how understanding takes place through the different levels. So what a child needs and how much of the information the child needs at different stages. So at the primary stage, the child must have curiosity towards the world and must be involved in joyful learning through exploration, observation, hands-on experience, leading to the development of scientific temper. So the important aspect at the primary level is the development of scientific temper through different explorations, observations, and hands-on experiences. And then the science should relate at this level to the society as a social enterprise, like it should be studied as environmental studies, with health being an important component here, so that whatever the child learns should use it, should able to implement the knowledge of health and environment in day-to-day life. Then at the upper primary stage, the principles of science are taught through hands-on experiences, experiments, where simple designs of science are prepared by the students, like filtration or distillation, or some kind of a simple kind of experiments or models are prepared by the students at this level. And diverse concepts in science must be inculcated through multiple learning experiences. So they should be having different ways of understanding a particular concept. And that's the reason we have here multiple learning experiences, not just with the lecture method, but with the demonstration, activity, field experiences, and through use of technology like ICT technology in this classroom. Okay, so different kinds of experiences must be there for the child to learn and understand the different concepts at this level. Moving forward, here we have the theme light. For example, if we take the theme, or we take up the example, the topic, that is light, and for this how the child should able to understand. So what are the objectives at this level? So the first thing, if the child is understanding light at the upper primary stage, then the child must identify transparent, opaque, translucent objects from the given materials by observing them through, distinguishing transparent materials from translucent materials, discriminating between shadow and image, inferring that light travels along a straight line by observing a candle through a straight and then through a bent pipe, making a model of a pinhole camera, concluding that white light is composed of 7 colors, that is VIBGYOR, by observing a beam of sunlight through prism. Yeah, these are very small and really we can do it practically. Performing an activity to understand laws of reflection using a plane mirror and pins, stating the laws of reflection of light, drawing a label diagram of human eye. So this is we have here the different activities here, where the child will be able to understand the concept of light at the upper primary stage. If we move further to the secondary stage, what must be there? So at the secondary stage, students are taught science as a composite subject. That is only like into a one subject. There is no deviations of further differentiation of science into higher level subjects like botany, zoology, physics, and chemistry. But it is a composite, it is a unified subject. More in depth in knowledge on diverse topics is imbibed through conducting advanced experiments, technological modules to verify and discover theoretical principles. So here they go on with conducting some more advanced experiments than compared to the upper level, and then they use some technological modules and they try to verify the theoretical principles. So whatever the principles are available in the science textbook or into their chapters and topics and lessons, they try to verify it through their hands-on experiences by performing experiments. So if we try to understand the same concept light at the secondary stage, how it will be. So here what the child is expected to understand at this stage is comparing the nature of images formed by concave and convex mirror, representing images formed by concave and convex mirror using ray diagram, writing lens formula, performing an activity to observe nature, position and relative size of the images formed by spherical lenses for various positions of the object, solving numerical problems based on the lens formula. So these are all the secondary stage activities depending upon the theme light. Next, we have describing the 3 defects of vision and the way of their correction. So how we can try to correct the defects of vision. Then explaining dispersion of white light through a prism, how it gets dispersed. So in the upper primary, we have seen that the light passes through a prism and there is a vibgeo color. That is only up to that level. But when we are moving to the secondary level, we have to explain dispersion here. Then applying the understanding of the phenomena of refraction to explain the blue color of the sky and red color of the sun at sunrise and sunset. So this is all about, we are moving into more advanced and more higher level phenomena. Next, here we see at the higher secondary stage, science should be taught as separate discipline, emphasizing on experiments, technology, and problem solving. So now it has into separate discipline. It has now become as physics, chemistry, botany, and zoology. And we are trying to perform experiments and we are trying to emphasize on technology and problem solving here. So it should be able to cover large number of topics. Instead of covering the large number of topics superficially, it should be able to see that the curriculum load is rationalized and treated with appropriate rigor and depth. So more in-depth concepts should be understood and not just superficially, but it should be more rationalized, should be thought with some reasoning, some logical reasoning should be applied, and we should be able to understand the concepts and the topics in depth. So at this level, if we say the similar theme light, if we say that we want to understand the similar theme light, then how could it be understood at the higher secondary level? So here, applying laws of reflection to explain total internal reflection of light, explaining formation of mirage on the basis of total internal reflection, describing technological application of total internal reflection in the form of optical fibers, driving expression for the refraction of spherical surfaces, driving expression for the focal length of combination of lenses in contact, driving expression for the refractive index of the material of the prism mathematically. So all these are mathematical solutions that we are applying. We are trying to see that how mathematical processes and problems are derived from these kind of explanations. Then performing experiment to draw the I sigma curve, and describing construction and working of a microscope and telescope, trying to understand what is the working aspect of microscope or telescope, how the lenses interact to get a larger image, and identifying errors in the given ray diagrams, evaluating suitability of spherical lenses for the construction of a microscope or telescope from the given values of the focal length of the lenses. So here we are trying to understand at the higher secondary stage with respect to the applicability of the mathematical and the logical problems, and we are trying to add here the mathematical aspect here, the physical aspect here. So what we are trying to understand is mainly the concept of light at the higher secondary level. So we are moving further and further, trying to understand the different theories and the laws, and trying to understand each and every aspect of it, like focal length, internal reflection, and these things to construct the microscope and telescope, how to do it, how the lenses are interacting together. So these are all used at the higher secondary stage. So this is what is the understanding and the appreciation level of the concept light at the higher secondary stage. Moving further, we really want to understand science, and we want to appreciate science. So the teacher has roles here to do, and the teacher must keep in mind that each learner is unique here. Every learner does not have the same capability of understanding the concept or a topic like the other children. So here the learner is unique, and depending upon the learner, the level of and the style of learning, that that type of the activity must be given to the child, and motivating learners to bring their previous knowledge into classroom. So from the like, if we are teaching the concept light at the higher secondary level, then the previous learning that becomes the secondary level, what they have learned about light. And if we are teaching at the secondary level, we can just ask questions regarding to the upper primary level, what they have learned about light. So in this way, we can try to bring out the previous knowledge into the classroom, and also what they observe around them in the environment, that also becomes as a previous knowledge, and what they have already understood about it, that all becomes a previous knowledge. So how the child is able to get motivated and trying to elicit the previous knowledge in the classroom. Then third is encouraging learners to raise and ask questions. Yes, child must always be, the should be provoked to ask questions, to raise questions. They should be encouraged to ask questions and to clarify their doubts, because at this level the child has a curious mind, and just keeping quiet in the class doesn't mean that the children are understanding everything. So that's important that the child asks the questions. Next is encouraging learners to correct materials from local resources. Yes, so the child must be able to encourage to collect materials from the local resources. Like, they have plenty of different types of mirrors, like convex mirror already available in the local in their local society, whatever their local area is. So they can collect all these materials, and they can form their own kind of a telescope. They can form their own kind of some model of trying to view the different things by having some kind of interaction with the mirrors, and they can just try to arrange the mirrors in such a way that they can try to view a particular image. So this is what. And then involving learners in teaching and learning process, trying to involve the learners in the teaching learning process. Yes, teaching and learning process is extremely important, and they should be involved over here, so that the child is actively engaged in the teaching learning process and in the learning and of the concepts and the phenomena. And then appreciating dialogue among learners. Yes, the children mustn't be only be instructed to keep quiet in the class, but they should be appreciated if they are having some doubts, or if they are discussing among themselves, and they should be appreciated for giving out some examples, or trying to tell a new concept, or which is related to the same concept, or trying to give some more different kinds of examples and all that. Generating discussions. Here must be seen that they try to generate discussion and argumentation in science. So it's extremely important that they are trying to generate the discussions and argumentations in science, where they want to see to it that how best discussing among the children, and arguing among giving some arguments, like the pros and cons of a particular thing, or a particular phenomena, or any kind of aspect they are trying to give out. Like, for example, if one subject is taken, like use of plastics, so the use of plastics can become a debate, like the pros and the cons, that is the advantages and the disadvantages of the use of plastics, and the pros and cons, the use of cotton bags or the rug bags, what are the advantages and disadvantages versus the use of the plastic bags. So such kind of discussions and arguments must be encouraged. So here I have that the more importantly here is if we are using the local environment and the resources available in the community, then the community will help it to introduce your students to new experiences. So all these activities are revolving around the using of the local environment. So by making the child very much near and attached, and really very much linking the learning with the society, makes the child really understand and appreciate science. So we cannot just do this larger aim, we cannot achieve this larger aim of understanding and appreciating science in the four walls of the classroom. So it's extremely important that we need to go beyond the four walls of the classroom and go to the nature, go into the fields, and really trying to understand science. So introduce your students to new experiences, aware students about the rich diversity around them, stimulate creative thinking, stimulate creative thinking of your students. Yes, they must try to think creatively. If would be there, this could be really happen in that way. So any issue you find in the society, and you give the children an idea like how creativity can be employed and how they can try to solve this issue in a different manner, then motivate your students to ask questions or to clarify their doubts, and motivate your students to do some kind of activities and all that. Develop a link with the local community. So we need to have here the ability to develop a link with the local community and link the curriculum to the everyday lives of your students. So we try to see to that how best we are linking the curriculum to the everyday lives of your students, until unless the everyday lives, the direct impact of science occurs in the everyday lives of the students. So until unless we have that kind of a connection, we cannot make the child appreciate science. So the science is only appreciated when the child really implements the knowledge of science in their everyday lives and solves their own issues. So that is what we try to link the curriculum to the everyday lives and develop a link with the local community. How to develop a link with the local community is by inviting the local, the locally efficient people to the school, and taking the children again to the community to have some kind of understandings and learnings and observations. Okay, so these are the different aspects with respect to understanding and appreciating science. Next, we go further to understand the different locally available human resources. So here there are many different locally available human resources which can really help the children to understand different phenomena in depth and more with clarity. So here we can call different types and specializations of doctors, healthcare workers, midwives, pharmacists, paramedical staff, dietitian, physiotherapist, psychiatrist, physicians with varied specializations such as cardiologist, neurologist, nephrologist, ophthalmologist, anesthesiologist, dermatologist, gastroenterologist, allied and applied science professionals can be invited to schools as resource persons for discoursing on significant issues in science and technology. So these are the different people, different human resources which could be invited on special days, or a particular timetable can be prepared where one guest can come and try to spend some time in the school in trying to aware the children about the science and about the importance of the science pertaining to their specializations. Like suppose if we call a dietitian here, and then the dietitian would be definitely asking the students what they eat in their in their the meals, or and how they are keeping up with their health, and what they do not like to eat and what they like, because children especially like the the street food, so the junk food, so it's not good for their health, and dietitian can explain the importance of eating healthy and maintaining their diet, because at this level nutrition is extremely important for them, for their cognitive and for their personality and overall development. So next we go further and see that there are also other physical resources available which are locally available, and these can be like science clubs, eco clubs, science museums, science fairs and exhibitions, field trips, science library, ICT in promoting teaching learning science. So all this can be also be available. And we also have government organizations like Central Pollution and Control Board, Union Ministries of Agriculture, Energy, Environment and Forests, Center for Cellular and Molecular Biology, National Institute of Nutrition, Indian Council of Agriculture Research, Indian Institute of Chemical Technology. Okay, so there are different diverse central and state organizations, state government organizations, where these can be added into the curriculum, and in a particular kind of timetable, or a particular annual year plan, or a monthly year plan, the teachers can take the students for a field visit to such kind of organizations, and they can observe how the things are going on, and they can understand the that really science is getting applicable in the society. Then next we also have here non-government organizations such as Nehru Science Center, Birla Industrial Technical Museum, Kishore Bharati, Jawahar Bal bhavans, etc., that plays an important role in teaching learning of science concepts. So Jawahar Bal Bhavans and Birla Industrial Technical Museums, all these are especially very important for children as a field trips where they can go and they can observe and they can really visit such kind of organizations, and they can perform their activities and they can win prizes, and such kind of activities must be organized and arranged by schools and the state governments. Okay, so we will now proceed further, and we will look into that what different types of questions has come depending upon this topic. And this is also an important topic, but much of the questions hasn't come from this topic, but it would be expecting that in near future maybe from this topic more questions would be asking. And here the first question is that which one of the following is the key expectation from teaching and learning of science at upper primary stage? This has come in the CTET September 2014. The first option here is to acquire questioning and inquiring skills. Second, to create literary literacy. Third, to appreciate the interrelationship between science and art. Fourth, to acquire academic excellence for competitive examinations. So among the four, what is the question? Which one of the following is the key expectation from teaching and learning of science at upper primary stage? So it is asking that which one is the key expectation? What do we expect to teach science at the upper primary stage? So not to create literary and literacy. Interrelationship between science and art, no, not much here. It has been mentioned. And for competitive exams, that too in the upper primary stage, no. The first one, to acquire questioning and inquiring skill. Yes, the basic thing, that is to first to acquire questioning and inquiring skills, extremely the key expectation at the upper primary stage. So first is the option. Next, we will see some of the important values of teaching science. Okay, so we have understood about the understanding of the science, how it happens. Now we are proceeding further in trying to appreciate science. So appreciation of science is nothing but values of teaching science. What are the values that can be inculcated among students once we teach science? So it's one of the important for individual benefits as well as for the development of society as a whole. So for science education, it inculcates intellectual value. The first one, that is, it inculcates the knowledge of facts, spirit of inquiry, the technique of assumption, the power of observation, value judgment, logical thinking, reflective thinking, reasoning, analysis, creativity, scientific attitude, curiosity, open-mindedness, and scientific methodology in the students. So all these are the important intellectual values which are taught through science in young children. Then next we have the utilitarian value. So in the utilitarian value, science has innumerable applications in our daily life. Nobody can deny this. And there are lots of fields like medicine, health and hygiene, communication, transport, various industries, technology, scientific gadgets, what not is being discovered and invented in these days. Everything has been, discovered and like invented, and so many inventions are happening into day-to-day life. And the achievements of science are vast in all spheres and abound the human life. It is trying to foster, it is trying to give prosperity to the human life, and the scientific knowledge is universal and has no boundaries. So it is like a universal knowledge, like it doesn't have any boundary, and anybody can use the knowledge of science and to use the knowledge and then to apply it into day-to-day life. That is nothing but giving it a utilitarian value. So many of like filtration, distillation, like filtering the coffee or tea and then distillation and all such kind of a small the activities what we do at our home, definitely it has an impact, and we are learning science through it. So it is nothing but a utilitarian value. And then we have the third one, vocational value. Science is a multidisciplinary, interdisciplinary, and transdisciplinary subject and creates a vast vistas of vocations. Science has brought an overall betterment of life of humankind. So one cannot deny this fact, because science is now a multidisciplinary. It has lots of different disciplines. It has its tentacles spread in different disciplines. It's interdisciplinary, where one discipline to another discipline has its own connections. Like we understand the biochemistry, we understand biophysics, So bio and physics, biophysics, biotechnology, chemistry. So all these are nothing but the interdisciplinary subjects. We have here transdisciplinary subject, where we are moving further into to the different areas of the disciplines and trying to understand from different angles a particular phenomena while doing research. So it's a transdisciplinary subject is it, and it creates a lots of vocations because it has its own applicability in different disciplines, though it tries to have a large number of a plethora of vocations where people can try to get skilled and get committed to a particular vocation. And then next we have the moral value. Science instills values like truth, beauty, goodness, honesty, patience, perseverance, determination, rational outlook, critical feedback, scientific reasoning. Science does not permit blind faith and superstition. So we do not have any kind of blindly we are not believing anything, and we do not have any superstitious beliefs in science. So science is very rational, it is logical, it is like we try to do the scientific reasoning, we come to a particular reasoning, and then only we try to accept the particular conclusion, and we critically give feedbacks. We have a rational outlook towards everything, and we have determination, perseverance, patience, dedication in performing science experiments. And overall, we should first of all see that we are true to our results in science, and we are giving the real and true values, and we are trying to record true values while doing the experiments, and we are trying to appreciate the beauty of each and every phenomena, the goodness of it, and the honesty. We are having the honest feelings, and we are trying to produce our results with honesty. Next, we have here aesthetic value. Instinct called nature the pre-established harmony. Pre-established harmony means it is already established. It is already having its own harmony. When we go to our nature, when we go to to the fields and the mountains and to the greenery, when we go there, it gives us lot of kind of like peace, and it gives a lot of happiness and joy, and that is what is the aesthetic value of nature. It relaxes our mind, and a science student recognizes the beauty of nature and appreciates it and make life worth living. And though through these such moral values, a science enthusiast ultimately appreciates every phenomena of nature. Yes, because when we see beauty in nature, we are appreciating our it, and we are making our lives worth living. Like for example, early morning we do yoga, so we want to do yoga in the open field, so we want to be near to the nature, and we want to really do yoga exercises in the nature, because we want to feel nature, we want to have everything absorbed inside us. So that is what is the we are making our life worth living, and we try to have freshness in our minds, and when we take a jogging or walking in the nature or field, so this all gives us a really peace, and it de-stresses and refreshes us. And through moral values, a science enthusiast appreciates every phenomena of nature, whether through a layman's eyes, even if the picture is a ugly picture, the science enthusiast looks it as beauty. Okay, then next, cultural value. Since the classical civilization to the contemporary civilization, science is a part and parcel of everyday life. The scientific knowledge helps in bringing about a cultural balance between the traditions of the past with the advances of the present, as they are undergoing constant change due to practical applications of the scientific discoveries. So from the classical civilization to the contemporary civilization, scientific knowledge has helped us to balance the culture between the different traditions and also the advances of the present day, and how we are trying to constantly undergoing the change in our lifestyles due to the practical applications of scientific discoveries. Today we have cell phones, smartphones, and the laptops. Previously this was not there, and we tried to struggle with the typewriter and all that. Now we have computer systems. So all this, nothing that we are trying to balance the new inventions into our lifestyle, and still we are culturally, we are having the value for it. So it has its own cultural value, and science is a part and parcel of the civilization. Creative value. it means that scientific hobbies motivates the student to become creative in their outlook. Science is a product of social value because of plethora of scientific innovations, instilling and aspiring young minds towards developing creativity in science. Yes, so whenever we want to have any hobbies or we want to utilize our leisure time, we try to do any kind of a scientific hobby, and we try to use science in our hobbies, and we try to make some kind of models or pictures we draw, and we try to do some kind of a projects, and it makes us do some creative activities, and it has a social value because lots of innovations that has been today, it is nothing but the product of creativity itself. And these scientists really inspired the young minds to create something and to develop some new products. Disciplinary value says that science brings mental and physical discipline in the life of an individual. Yes, because disciplinary value, it's like a student of science must be disciplined. That person must be having to develop a personality which fits in to undertake scientific endeavors. And development of scientific attitude and training in scientific method is crucial to be a science student, because a science student must have the scientific attitude and must implement scientific method in doing or performing any experiments or projects, so that that person can get a successful in that particular project or in their endeavors. So that is extremely important, that science develops a personality of a person in a way that it helps the person to do science experiments. And then next, equity value. All children need to be encouraged to participate in responsible use of science and technology for the benefit of society. So we are here giving equal values, and society and schools must assure educational excellence by overall development of students, and diversity should be valued. So diverse, that is they are different children in the society, and all children must be seen to be that they are able to utilize the benefits of science and technology, and there must be having the overall development of all the children irrespective of their strengths and weaknesses. Then we have here the questions related to this topic. The first question here is, the best method for developing understanding in science in children is, the options here given here are, help children, help them carrying out scientific experiments, stay them away from experiments, third, make them busy in social activities, fourth, to read biography of scientists. So out of these four, which is the best method for developing understanding in science? So whether they should be helping them to carrying out scientific experiments, or staying them away from the experiments, making them busy in social activities, or to just make them to read the biography of scientists. So understanding can be done only when they apply the knowledge. So that is why the first option is correct, that is, help them carrying out scientific experiments. Next, which of the following can enhance critical thinking among children? Asking children to read science textbook in class, asking children to supplementary material in class, to read a supplementary material in class, or and asking children to discuss among themselves in groups and followed by a sharing in large groups, demonstrations of experiments by the teacher. So among the four, which one is the right answer for this? To enhance critical thinking, shall children be asked to read science textbook only, or supplementary material only, or to discuss their among themselves in groups and then share whatever they discuss among their large groups, or to demonstrate of experiments by the teacher? So how the critical thinking will develop? Critical thinking will develop with the third option. They must be asked to discuss among themselves. Critically, they will think that what other person will think and what they will think, and they will critically think each other's viewpoints and opinions, and then they will try to share that in the larger group. So third is the best option. Now next we have here, no success is achieved without being truthful. Comes under which value? No success is achieved without being truthful. So truthful is one of the important aspects here. So is it a disciplinary value, moral value, utilitarian value, or cultural value? So which value is it? So no success is achieved without being truthful. So truth and honesty comes under moral value. So the answer is moral value here. Okay. So this is with some important questions under this topic. and hope you have understood today's topic, and looking forward for you to join in with the next upcoming sessions. Till then, stay tuned, take care, and keep learning. Thank you so much.